Today we are going to solve the problem 5.5 of Griffith third edition Introduction to Quantum Mechanics. I have already uploaded one video for solving this problem, but here I am going to do it in a very simple way with more conceptual. This problem consists of two part. One is part A is write down the Hamiltonian for two non-interacting identical particles in the infinite square well. Verify that Fermion ground state given in example 5.1 is an eigenfunction of Hamiltonian with the appropriate eigenvalue. So first we will see one by one. First we have to write down the Hamiltonian for two non-interacting identical particles. So the particle does not interact. So the Hamiltonian is equal to the total Hamiltonian is equal to the Hamiltonian of particle 1 plus the Hamiltonian of particle 2, which can be written as h cross squared over 2m delta 2 over delta x1 plus delta 2 over delta x2. So this is the Hamiltonian. The lowest energy of the antisymmetric, that is fermionic facial state is psi of x1 and x2 is equal to 1 over square root psi 1 of x1 psi 2 of x2 minus psi 1 of x2 multiplied by psi 2 of x1. Here it is antisymmetric, so we got the negative sign. If you exchange x1 and x2, you can see x1, x2 interchange. If you interchange it, you will get negative sign. So if you interchange, the sign will change. So that is anti-symmetric one. So we have seen that psi of x1 and x2 is equal to 1 over square root of psi 1 x1 psi 2 x2 minus psi 1 x2 psi 2 x1. So x1 x2 interchanged. So naturally, this is a negative sign. When you are swapping the position, you will get a negative sign. So now, what will happen when Hamiltonian act on this total wave function, which is equal to h1 plus h2? So, which act on the first wave function and the second one? So, linear combination. So when H1 plus H2 act on this wave function, you will get energy level E1 plus E2. Since E1 plus E2 is a number, you can take it out. So you can analyze this red color point, which is 1 over square root 2 and this one. So which is nothing but the total wave function. So naturally, if wave function psi of x1 and x2 is wave function for Hamiltonian H, then this linear combination also the uh, wave function of the same Hamiltonian with eigenstate E1 plus E2. So when Hamiltonian act on the wave function, you will get energy level E1 plus E2, the psi of H1, H2. Hence here, psi of x1, x2 is an eigenfunction of Hamiltonian. We have proved it. Then their eigenvalue is E1 plus E2, which is equal to E1 is n squared. E1 is 1 squared plus E2 is 2 squared, which is equal to 5. So 5 times this ground state energy. Ground state energy, that is nth energy state is that is En. Nth level energy state is we know n squared pi squared h cross squared over 2ma squared. So here n is 1, then this will be pi squared h cross squared 2ma squared, which is nothing but E1 when n is equal to 1. Then we will move on to next session. is find the next two excited state beyond one gives in the example. The wave functions, energies and degeneracies for each three cases, that is distinguishable, identical boson, identical fermion. First, we will take distinguishable. That is the next energy state is we have seen psi 1 ground state energy. Now, next excited state is psi 2. So, which can be written as psi 2 of x1, psi 2 of x2. So we can distinguish between these two. The energy, but however, both are at same energy state. So E22 is equal to 2 squared plus 2 squared, which is equal to 8. So E22 is 8 E1. This is non-degenerate. We can distinguish, but both are at same energy level. So now next energy state is 1 3. So 1 3 can be written as psi 1 of x1, psi 2 3 of x2. Similarly, psi 3 1 is equal to psi 3 of x1, psi 1 of x2. Both the energy levels are same. That is 1 squared plus 3 squared is 9. 9 plus 1 is equal to 10. So 10 E1. So E13 is equal to E31, but we can distinguish between these two level because the particles are distinguishable. So we have doubly degenerate. These two states are having same energy level but different state. So doubly degenerate. Now we will move on to identical boson and identical fermion. Now, what about the identical boson? So, ground first excited state is psi 2 2, which is equal to psi 2 x1, psi 2 x2. The boson are identical, you cannot distinguish between them. So, here the energy level is 2 squared plus 2 squared, which is equal to 8, 8 times E1. E22 is 8 times E1. This is non-degenerate. Similarly, what will happen when psi 1 3, that is one particle is at the ground state, other one is a second excited state. So this can be written as a linear combination and is identical boson is a symmetrical one. So you will get plus sign. So 1 over square root 2 psi 1 of x1, psi 3 x3 and psi 3 of x2 plus psi 3 of x1 and psi 1 of x2. So we have interchanged the particle position, but it is addition. So even if you change the particle, nothing will happen. No, there is no change in sign. It's a symmetrical one, and also it's you cannot identical particle. You cannot distinguish between psi 1 3 and psi 3 1 as we have seen in the distinguishable particle. So here we have 1 squared plus 3 squared is equal to 10. So you have E13 is equal to 10 times E1. This is non-degenerate because there is no difference between psi 13 and psi 31. You cannot distinguish between these two states. Now we will see for identical fermions. So fermions are antisymmetric one. So you cannot have the state like psi 1 1. That is, no two particles can occupy the same energy state. So 1 1 and 2 2 are not allowed. So first excited state is psi 1 3. So this can be written as 1 over square root 2 psi 1 of x1 psi 3 of x2 minus psi 3 of x1 psi 1 of x2. Because it's identical, there is no difference between psi 1 3 or psi 3 1. So here the energy level is 1 squared plus 3 squared, which is equal to 10. So 10 E1. Similarly, side 2, 3, because you cannot have side 2, 2. So next energy state is 2, 3. However, this is the identical particle. There is no difference between side 2, 3. You cannot differentiate side 3, 3, 2. So which is equal to 1 over square root of 2 psi 2 x1 psi 3 x2 minus psi 3 x1 psi 2 x1 x2. So this is also a single state, that is e2 3, that is 2 squared plus 3 is squared. 9 plus 4 is equal to 13. So 13 E1. Here both are non-degenerate. Uh, Thank you very much for watching my video and supporting me continuously. Thank you very much.